In this video, I'm going to show you a method by which we can automatically populate a small area of a scene. In this instance, I'm using Unity, and I'm going to be using a little script that I've written. I'm not going to show you the code, but you'll have access to it. I'll share the code with you, but I'm not going to show you the code in this particular tutorial. We're going to be using a method that's called RayCast, which is very similar in principle to the way that a ray trace might work. RayCasts in Unreal are generally referred to as traces, but the fundamental method by which these all work is called ray trace. And if we have a look at this terrain that I've made, this is a Houdini terrain. So I've done various parameters in Houdini to output the terrain and the color map or the albedo. It's actually this is in Unity and it's about 1 kilometer square, but actually this type of terrain this would be significantly larger than 1 kilometer in real life. In games, we do tend to have a bit of a stage makeup aspect to the way that we work with terrains, and we tend to condense space and we exaggerate forms and such, just so that the player isn't having to traverse for many real-time days over the course of a landscape. So what you'll see here is the color map it's an 8K map. If you zoom in quite close, you start seeing the individual pixels. So this type of setup is really good for a Vista style arrangement where our main game world may well be in the center here, and the rest of the world is around that point, or our main player area is in the middle, and then the rest of the world is around that point, simply because it's not particularly high resolution, so you can get away with a lot of detail for not very much memory footprint. This isn't the sort of terrain that you would normally be walking over as you play a game. You would normally have higher detailed localized terrain for that. Okay, so that's what we're working with. And I've positioned the camera. This is the position of the camera in this space. And what I would like to do is I would like to populate this area here that I'm indicating with the mouse with some assets. It could be rocks, it could be plant life and all that type of stuff. So I'd like to be able to place some objects over there, and I want quite a large number of them to start filling out the scene, but what I don't want to be doing is manually placing them there, because that's going to take time. Now, luckily, most game engines do come with an inbuilt procedural generation system built into the terrain editors, so you can paint a bunch of assets on. And many of these systems have brush masks or fill masks where you can only paint things on an area of the terrain that's above a certain height, for instance. What I'm going to do is I'm going to show you how you might build out that type of basic system, or at least how you might use the custom system that I've written for that, and then I can show you the various ways of controlling such a system. So the first thing I'm going to do is I'm going to create a asset that we will be able to use to debug or test our scene population. In this case, what I'm going to do is just use a simple sphere. Actually, let's use a cube, because then I can show you some interesting use cases for this. So we'll use a cube. I'm just going to drop that in there. And I'm just going to scale this up, because this is quite a large landscape, and I say large, it's 1 kilometer by 1 kilometer, but if our cubes are just 1 meter by 1 meter and they're scattered all over the place, it might be quite hard to identify where they are. So let's just make them a little bit bigger so that they take up more than just a subpixel on the screen. So there is my cube, and I'm going to create a new material. Let's call this high vis, and I'm going to give this a very bright and contrasting color. So green is probably a good one for this. Actually, let's go with pink, just because that's there's a bit of pink in here. You want to choose a color that's going to contrast with everything else in your scene. So high vis pink or yellow or green is generally quite good for that. Let's drop this on. That might blend in a little bit, so I'm going to just change the color to green. There we go. That stands out a little bit better. Okay, so that's our cube done. What I need to do now is turn it into a prefab. So I'm just going to shift that down there, and then I can delete it from my scene. So I've got my cube available down here in my assets. So next up, I've already written the script, so it's all ready to go. So all we need to do is instance it within the scene. So I'm going to create a new empty game object. I'm going to call this spawner. Okay, and this is currently located at the exact same position as my camera. So that means everything will spawn around the camera. Okay, which isn't exactly what I want, but I can probably control how it works. But we'll use the camera as a starting point, the camera position as a starting point. So here's our spawner. There's currently nothing on it, and it's empty, so you can't see anything. So let's add our script, which is this PCG scene population script. And this is going to give us a bunch of parameters that we can control. The first one we're going to change is the radius, and this is basically how large of an area do I want to spawn things within. And this is maybe a little bit hard to see in this particular scene, but you can see that when I manipulate radius, it's giving me what we call a gizmo, which is basically like a 3D, a drawing of a 3D object, essentially. It's not an actual 3D object in our scene, it's just it's almost like a guide. And this, in this case, this sphere shape is indicating the radius that I've put in here. So if I put in a larger radius like 500, then the sphere will be quite large. Okay, so you'll see, our landscape is 1 kilometer, the radius is 500, so therefore the sphere almost takes up the entirety of the landscape, except for this bit over here. Okay, we can leave it as 500 in the radius for now. The next one is quantity, so how many things am I going to spawn? So I will choose 1000 for now. RayCast distance is the distance within which we're going to be raycasting from. And what a raycast does is it will shoot a line, or it will draw a line from one particular point to another point, all right, or along a distance, so say between 0 and 100, and it will detect whether it hits anything, and it will detect what it has hit. Okay, and there's a bunch of other details that we can pull in from a raycast, which are very, very useful for us when it comes to scene population. And in this case, this is really helpful, because what we don't want to do is, if I want to populate this area up here, but I don't want to populate down here, which is essentially a lake bed down here, then I need to make sure that my assets aren't falling into this area accidentally when I automatically populate the scene. So I need to have some kind of control over that. And by drawing a raycast, I can determine at what point on the terrain, right, my object is going to spawn at. And if it's below a certain height, I can say, don't spawn it there, right? Put it somewhere else. So that's essentially what this script is doing. Right, so we've put in a raycast distance of 100. That's probably overkill, but it's absolutely fine. It's not particularly expensive. Overlap is what distance is it going to look for other assets? Because what we don't want necessarily is we don't want things crashing into one another, so you've got objects clipping through one another. So it looks for other assets within this type of distance, or a distance of 1, which is 1 meter in Unity. And then there's a layer here, which is going to be the layer in which it populates with the assets. In this case, I've already created a layer in Unity called scene pop. So that's for my scene population assets. And the next layer it's asking for is where is the terrain layer. Because what I'm doing is I'm casting a ray and I'm testing whether it hits a point on the terrain. I don't want anything else to interfere with that. So therefore it's a very cheap method to optimize a raycast is to have the things that you are raycasting against in a specific layer. Unity is particularly optimal with this type of stuff. So the layers system in Unity is very, very useful for optimizing little bits of code like or functions such as raycasts. So let's select the terrain layer, and my terrain, so I'll just show you here, is already on the terrain layer. Okay. Right, so what next? There's this little option called Orient to Terrain, which I'll show you what that does in a minute. We've got a range for scale, which is it's going to vary the scale between these floats. We've got a seed, and the seed is really good because it makes the system deterministic. So what I've done is I've set the seed, and the whole system is driven by the seed number. So I can change the seed number and then to find one that I like, and then I can cycle back through them if needs be to get back to the one that I preferred better, you know. So I can always go back to the original seed, which is really good. Height placement is at what height are these things going to be placed, and I've got a couple of different values here. This is just a vector 2. It's XY, but you can ignore that. It's just a vector 2. The first one is the lowest position, and the second one is the highest position. So if I type in 50 here, then they will be placed up to 50 meters off of world 0. Okay, so they'll go up to 50 meters high. Right. At the top of the script, I've got a list, and if I hit the plus icon, I can add another thing to that list. I'm just going to add my cube in here. These are the objects that are going to spawn. So you might have a variety of different rocks or plants, and you can just add different things to the list if you so wish. In this case, we're just going to use one object. Right, so let's hit play and go into game view and see what happens. Right, so right away we've got a bunch of randomly spawned cubes. The console is giving me a readout of how many it was able to create. It was able to create 934. Some of them probably fell off the side of the game world because the radius goes out there. And you can see that they're being spawned at many different heights, and we're getting some on our lake bed here, but I just want them to be up here. Okay, so we need to be able to control this. Now, in terms of procedural generation, how much of this is procedural? Well, we've been able to define a radius, and we've been able to define a quantity, and we've been able to fill that radius with a quantity of cubes. But that's fairly straightforward. You know, the cubes are randomly placed. There is quite often a an incorrect conflation with randomness and proceduralism. In most cases, random is not a particularly desirable aspect to have in a procedural system. Randomization does let us view the potential outputs, or what we call the possibility space, of a procedural system far more easily than it would do if we were cycling manually. But beyond that, it's not a particularly desirable thing to have. Like, I wouldn't want these necessarily to be at a random height. I would like them to be at a height that I can control. So proceduralism for me is when we start taking control of the system, okay, and creating systems that we can control rather than just randomly splatter stuff everywhere. So what I'm going to do here is, and I should be able to edit this live because I've coded this in, I'm going to adjust my height placements so that they don't place at a height of 0 and upwards, right? I'm going to change my initial height placement, or my lowest height placement, to 20 meters. So I'll just change that to 20, and you can see that now the cubes in my scene are only spawning above a certain height. It's that level of control that makes something procedural, for me at least. And so now all of my green cubes are all spawning up here, which is where I wanted them to spawn. Now, another cool thing that you can do with a RayCast, we've got some that are clipped through one another there, and that'll be because of an error in the overlap isn't big enough, essentially. The cubes are scaled up a little bit higher, and the overlap wasn't big enough to pick up that one there. So we can fix that in a minute. But one of the cool things that you can do with cubes is you'll see that some of these have dropped on slopes, and they're still pointing straight upwards, and that's fine if you want something like trees, but you might want something to follow the terrain. So what we're going to do is we're going to come out of here. So I've just come into edit mode rather than play mode, and I'm going to adjust a few of these numbers here. Let's go for an overlap of 2, and let's see if that fixes the clashing issue. We can also determine when a ray is cast from an object. So let's say a ray is being cast down here I'm just drawing this with my mouse, in this direction and hitting the terrain around here. We can determine the difference between the angle of incidence and the normal, which looks to be pointing in this type of direction. So we can determine this angle between the direction in which the vector in which the ray was cast versus the vector in which the object is facing, and that gives us an angle, and we can use that to rotate the objects, which means normally if you're using a terrain-based population system, this might be called orient to terrain. So that's what I've called mine over here. So I'm just going to turn that on. Okay, and let's have a little bit more variation in here. So I'll go to 2.5, and let's see what we get. Okay, and you'll see that the cubes that I've spawned are starting to orient to the terrain that they are on. Okay, which is kind of cool. And they're also looking over a wider area for collisions and such, which is quite helpful. Just means that they're far less likely to just spawn inside one another. And it's pretty cool now that we've got this level of control over where they do and do not spawn. Alright, so what we're going to do now is I'm going to replace these cubes. Now that I know my system is working, I'm going to replace these cubes with some slightly better assets. Now, these assets are not fitting with the terrain that I'm using. These are just the default Unity like plant assets that you get with their terrain system. So what I'm going to do is replace my cube with some of these assets. So these are not going to look amazing, but we'll just use them just for demonstration purposes. So I'm going to add about, let's just add a bunch of them, shall we? So I'm adding these into my list, and this is just a random selection. I said random is not desirable within a procedural system, but I'm doing it deterministically using a seed, which means I can replicate all of this. So it means that when I close down the scene and it randomly generates things again, they will be exactly the same as the last time, i.e. not actually random. We've got some grasses here as well. There's loads of stuff in this kit. And likewise, you might have a bunch of assets from Megascans or something that you're using to plug into your procedural system. Hopefully you've got some stuff that you've made as well, which would be great to see. Okay. I think that'll probably be fine for now. There are a few other things here as well, but we'll just leave it at that because otherwise we'll be here for ages. So what I'm also going to do is I'm going to tighten up the area in which I'm populating these assets. Generally, you wouldn't want to necessarily procedurally generate assets across this large area. You can do that, and you can produce some. You can, create some really fantastic tools that really help you to control that. However, I would argue that Houdini and such and the tools built into Unreal and Unity are already good enough for that type of work, and you don't need to start building your own PCG for scene population unless you really want to get into sort of technical art and all that type of stuff. So what I'm going to do is I'm going to tighten up the area in which this is being spawned. So I'm going to tighten this up to about a 100 meter radius, so it's much tighter, and I'm going to drop it specifically over that area that I've been talking about. So it's around about here. I might need to play around with this. Using this wire sphere doesn't make it particularly helpful in terms of identifying where things are going because it's semi-transparent. Or at least it's transparent between the wires. So what I'm going to do is I'm just in my code editor here, and let's just bring this over so you can see it. The code that I give you is going to be all commented out. I just wrote this up today just for this demo, so I need to add some comments and stuff, and delete a bunch of stuff as well before I hand it over to you. But here we've got this function called onDrawGizmos, and then here I'm drawing some gizmos. You see the color is red, for example. And currently I'm drawing a wire sphere. I'm going to switch that just to draw sphere, and I'll save that and jump back into my scene. Okay, and now we've got an actual sphere where we can see. Now you can see right away why I don't want to, why I prefer using draw wire sphere than this, but this is okay for now. And this gives you a slightly better indication of where the things are going to be in the game view. All right, and we can turn on the gizmos as well in the game view, so I can actually see those, and yeah, I can see okay that looks to be in the right area. Okay, so let's see the results. So I'm going to hit play, and let's go into our game view. Now these things are going to be super small, I expect, because they're actually really small plants. So let's go into our scene view and turn off gizmos and see if we can see any. You can see them all here, look. Okay, so you can see this area that's been populated by all of these objects, and they're just very hard to see because they're quite small, and they'll be occupying less than a sub-pixel on our actual render. So that's why I chose to use the cubes previously. Okay, so yeah, those are the plants in the the scene view, and none have spawned below a certain height, so you're only going to start seeing them above a certain height. So this is a really useful system if you've got a small area that you would like to populate. But the script I'm going to give you is the starting point really for building out your own procedural system if you would like to do that. For those of you who are interested in being technical artists, I would absolutely encourage you to learn the ins and outs of using RayCasts for scene population, and the way that you can construct masked areas by analysing the results of a RayCast. Okay, that's it. Thank you very much.